Now let me see here some of the examples here. The maximum number of electrons in a shell. Already we discussed this one. We can put 2n square number of electrons. If I want to put electrons in the third orbit, so maximum I can put how many electrons? 2 into 3 square, that will be 18 electrons. So this is what actually see in K shell, L shell, M shell, N shell, O, P, Q shell. How many electrons we can have? See this much number. By using which formula we are writing here? 2n square formula, right? Now see in K shell we have only 1s orbital. Okay, and in L shell we are going to have 2s orbital and 2p orbital. In M shell we are going to have 3s orbital, 3p orbital and 3d orbital. In Nth shell we are going to have 4s shell, 4s orbital, 4p orbital, 4d orbital and 4f orbital. So as shell increases, what happens? Number of orbitals also increases here. So here in s orbital we can put how many? Only 2 electrons. In p orbital subdivide into like this, no, like this. It is subdivided into like this. So you can put here 2 electrons. You can put here 2 electrons. We can put here 2 electrons. Total how many? 6 electrons. Similarly, again, what happened? S orbital we can put 2 electrons, isn't it? And p orbital same. You can put 6 electrons. What about d orbital? How many we can put here? D subdivide into 5 orbitals, isn't it? It can subdivide into 5 orbitals. So we can put here 2, here 2, here 2, here 2, here 2. Total how many? 10 electrons we can put. So here, again, here also what happened? 2, 6, 10. What about f orbital? In f orbital, how many electrons we can put here? See, 1, 2, 3, 4, 5, 6, 7. Now we can put here 2, 4, 6, 8, 10, 12, 14. Now we can put 14. That means each orbital we can put 2 electrons like this. Now, for example, let me see for hydrogen atom, what will be the electronic configuration? The electronic configuration of hydrogen atom. Atomic number is 1. The electronic configuration will be 1s1. Now, for hydrogen atom, electronic configuration is 1s1. N is equal to 1, right? S orbital it is S orbital. L value will be 0. And for all S orbitals, M value will be 0. And the electron, the first electron always will be in this state. Therefore, S will be. Okay. As there is only one electron that we can take in clockwise direction. S is equal to plus of here. I will take what for helium. For helium, Z is equal to 2. Electronic configuration is 1s2. And for this first electron, there are 2 electrons are there, no? First electron, let me take 1. For first electron, for this one, okay? 1, N is equal to 1, yes. S orbital, L is equal to 0. All S orbital, M is equal to 0. Now, first electron is which direction here? Upward direction. Therefore, isn't it? It will be less of. Now, for second electron, same. N is equal to 1. S orbital, L is equal to 0. M is equal to 0. Now, the second electron, if you observe here, what happened? The second electron, if you observe, that is in which direction here? Downward direction. Now, S value will be minus. So, for helium, isn't it? First and second electrons, they are having same N value, L value and M value. They differ at where? Spin quantum number. They differ at spin quantum number actually. To take for lithium. Lithium atomic number is what? 3. Electronic configuration will be 1s2 and 2s1. Okay. Now, first electron, this one I am taking. First 1s2 I am writing like this. 1s2 we are writing like this. 2s1 also we can write like this. Now, in this case, this indicates for 1s2, 1 indicates what actually? N value, L is equal to 0, M is equal to 0. The first electron upward direction, less of it is. Second electron, n is equal to 1, L is equal to 0, M is equal to 0. Second electron is which direction it is? Anti-clockwise direction. Therefore, I have taken -1. Now, third electron, if you observe third electron. Now, this is actually having configuration 1s2. This configuration is having 2s1. This is third electron I have taken. Now, for third electron, the configuration is what here? 2s1. For third electron, the configuration is 2s1. Now, then you need to take what? For 2s1, n is equal to 2, L is equal to 0, M equal to 0, and this first electron always will be in upward direction. Second electron always will be downward direction. S will be what here? Plus of here. So, in the case of this one, n are same, but the difference in quantum number in the case of first and second electron. But in the case of first and third electron, they differ in the principal quantum number. You observe this one, they differ in where? Here it is, they differ, isn't it? Next, I will take some more things actually here. Writing configuration. For example, I want to write the configuration of the phosphorus. Right? An example, let me take here. First of all, you have to take atomic number of phosphorus will be 15. Okay, right. Now, what according to the Hobsbawm principle, we have to fill like this. First 1s orbital, then 2s orbital, then 2p orbital, then 3s orbital, then 3p orbital. In this way, we need to fill. Okay. Now, in 1s orbital, we can put how many electrons here? 2 electrons. Similarly, in the 2s orbital, we can put only 2 electrons. But in the p orbital, we can put how many maximum? 6 electrons. Again, the s orbital, we can put here 2 electrons. In the p orbital, we can put maximum 6 electrons. But how many available? If you see here, availability is only 15 electrons. But already we have consumed how many? 6 plus 2, 8, 8 plus 2, 10, 12 already we consumed. Remaining only how many we are having? 3. That we can put here. This is will be 3p3 electronic configuration. Okay. Now 3p3, how to make 3p3 quantum number here? So 3p3, for 3p3, n is equal to what? N is equal to 3. L is equal to 1 because it's being a p orbital, L will be what here? 1. What about ml value? For writing ml value, you need to take 3 orbitals like this. 1, 2, and 3. Now put these 3 electrons in half fill configuration like this. Put in this manner. Now third electron will be this one. It will be the third electron for us. This will be the first one, second one, third one. Now ml values we need to write 0, -1, +1. Now ml value will be here +1 and ms value will be, isn't it, plus half. So we got all the 4 quantum numbers for what actually 3p3 phosphorus. Okay. For example, if you take what happened, chlorine if I take atomic number that equal to what? 17. Now again we write according to Hobsbawm rule 1s, 2s, 2p, 3s and 3p. Now put here again 2 electrons in 1s, 2 in 2s and 6 in p orbital, again 2. Here the total present only 17 electrons. Already we consumed here 6 plus 2, 8, 8 plus 2, 10 plus 2, 12. The remaining we have tried only 5 electrons left that we can keep here actually. 3p5. So this will be the configuration of what? Chlorine. 3p5 is the configuration of chlorine. Now we are writing the quantum numbers for 3p5 here. How to make quantum numbers for 3p? Again, I am writing quantum numbers for 3p5 here. Okay, right. Now n is equal to 3. L is equal to what here? 1. Again, ms is equal to what we write? 3p5 means you write like this. 3 orbitals you take here. 1, 2, 3. 1, 2, 3, 4, 5. Here the electron. 5th electron is here. This is the 5th electron. Okay. Now put here it is 0. It will be -1. This will be +1. Okay. Now ms value will be here 0 because the electron present in this magnetic quantum number. Now what will be the ml it is. What will be the ms value here? The ms value, it is in downward direction. Now put it is what? -1. In this way we can do n number of problems. Now let me take last example now. Take one more example. last example we can take. That example is you'll take something. I will take something. Sodium is completed. No, we'll take sulfur. Will take sulfur. Okay, sulfur will take it. Atomic number of sulfur will be 16. Now, first of all, 1s orbital, then 2s orbital. This is according to Hobbe principle. 2p orbital, then 3s orbital. Finally, what happened? 3p orbital. Now, first of all, we can put maximum in 1s, 2 only. In 2s, maximum we can put. In 2p, we can put maximum 6 electron. In 3s, maximum 2 electrons. What about the 3p? How many we can put here? See, 6, 2, 8, 8, 2, 10, 10, 12 we got actually. So remaining will be what? Only 4 electrons we are having left here. Now these left 4 electrons we are putting there here. So it becomes 3p4 now. For 3p4 we can make what? Quantum numbers here. Now n is equal to here 3. L is equal to 1 because it is a p orbital. Now what about ml value? Ml value again make 3 orbitals per p. Okay. Now put first electron, second electron, third electron and fourth electron. Now it will be 0, -1, +1. Now the fourth electron in present in the -1. Fourth electron in -1. Now ms will be in downward direction. It will be also -half actually. This is about how to fill the electrons if they given any atom. Otherwise, if they given electronic configuration, we can write all these quantum numbers.